Good morning. I'm Arno Schwab. I'm an account manager for KETIV, and my co-host is Jorge Fernandez.
Hi, everybody.
So today, the purpose of this webinar is for all attendees to learn how quick and easy it is to use the Autodesk solutions in order to design a structure from scratch, also to be able to perform some design validations and have access, full access to documentation for manufacturing purposes. When it comes down to designing skids, it is very important to be able to get your design right the first time around, for such factors as basically, long lead times on material, and being able also to put the structure together and make sure that the structure is sound and is going to be durable. And that's what basically Jorge is going to show you this morning.
Yeah, thanks, Arno. Also, I'd like to welcome Jeff Strain. He's on the call with us. He's another one of the Autodesk gurus that we have, in contact with Autodesk, and he's on the call too, and he can help us answer questions as we go. So with that, actually, I want to remind everybody that there is a chat panel in the GoToMeeting control panel. That if you have any questions, any concerns, let us know. And there is a questions panel as well, so you can put your questions in there. We'll look at them all at the end and try to answer as much of it as we can. To elaborate a little bit more about what Arno was talking about, when we thought about today's webinar and what we wanted to show you, we wanted to make sure we went from start to finish. A lot of times we'll look at customers and you might be in the middle, you might have not known exactly everything you need to know. I wanted to give you just a little more background about if you're starting a design structure, how we design it in case you're newer to Inventor to the Autodesk solution, then how we want to actually validate it, and finally at the end we all need a cut list. Sometimes we're going straight to fab, and that's good, that's great, I encourage that more, but there are times where we need to have a cut list, and we'll do that. We know it's important that when it comes to buying this material, for example, the stock material for a skid structure, you want to make sure that you order it on time, right? There's some long lead items sometimes, so it's really important to get it right the first time. Can't stress that enough. I'm sure you're experiencing that today, and you try and get it right the first time. You don't want to make changes. We also talk a lot about over-engineering these products, so we'll talk about these subjects today. So with that said, let's start getting into, I'm sorry, one more thing. I'd like to also say thank you to Cabelco. I was working with Juan from there to better understand a little bit the skid structures and how they work, and we'll actually be using just a small portion of that in today's webinar is what we plan. So thank you, Juan, and here we go. So the first thing we're going to look at is the frame design. What happens a lot of times is you have a constrained area, a confined space to work in. We want to make this as quickly and as easy as possible, as well as try and automate some things, whatever we can, without making it too difficult, and be able to treat the end treatments to these members easily. So we'll go into Inventor and we'll do just that. In Inventor, I have a quick example here of a skid that we've got, and there's this platform on the right to do some maintenance work on it. So what we're going to do is we're going to start creating this platform from scratch so you can see exactly what it entails. There's a lot of different ways to start it. I'm going to start off here by, well, first I'm going to turn off the visibility of this skid so we can make it on our own. And inside of the tools of Inventor, we have the ability to create assemblies and parts right inside. Another thing I'm doing, by the way, that you'll see in the background is I'm actually using this skid inside a vault. So I'm able to take advantage of things like being able to say, well, I want to start a brand new assembly and use the automatic numbering scheme inside of there so that I don't get confused later. So we'll go ahead and start using that as we start working on this and using the assembly template, and we'll go ahead and put it in a folder that we decide as well. All right, with that set in place, we'll go ahead and start our assembly, and we'll just place it out here for now. The first thing we need when we're starting this frame is we need a skeleton, something that these members are going to follow. So now that I'm working in the context of these assembly and now sub-assembly, we'll be able to create the skeleton model itself. So we'll just simply create another part, Here we'll just make it sequential for now for the actual frame piece, that's the skeleton piece that's going to be used here. We can still add more information to this, by the way. It doesn't just have to be the automatic numbering scheme that comes in here already. Standard part. Now that we've done that, we're ready to start this new component, and we're going to put it on the skid. We have this confined space we're going to work in, so I'll just simply start a brand new sketch on here to be able to start making that skeleton. We'll look at a top view here, makes it a little bit easier. And we'll just use some simple tools here to be able to start laying this out. You're seeing me type in these dimensions, so automatically they're already being made into parametric dimensions. And then it allows us to be able to view this correctly, right, and be able to have parameters that we can later on change if we need to as well. We could have also attached all of this to the actual, to the frame itself so it adapts to it if we wanted to. Not necessary, but it is something that we can do. But here I'm able to see, of course, exactly what it's going to look like as far as that maintenance platform and the envelope of it, if you will, and make sure that I'm not intersecting any other spaces. For purposes of this, we'll just go ahead and make this part clear, actually, so that it doesn't get in the way. We can see through it and start to see the members we're going to start using in just a moment. So we'll return back up to our assembly level that allows us to go ahead and save this so we can continue forward. And now I'm going to use something inside of Inventor called Frame Generator. So this is going to give us the ability to be able to say, well, I want to start inserting some frame members here from structural components, right? What's going to be good, you're going to see this in a little bit, just kind of giving you a little preview. We're going to be able to reuse this information, and you'll see how we're able to break it down when we get into the validation phase. But for now, we can see all the different types of tubing inside of here that comes automatically. You know, it comes out of the box inside of Inventor. So in my case here, I want to use some channels here. We'll use a U shape. Here it is. Whoops, went too far. And we'll choose the size. Now, a lot of times we might say, I want this to look sturdy, right? But what if I wanted to go just a little bit less? Usually I might use a C6 or something like that. Maybe I'll go with a C3, for example, just to show you how easy it is to work with this stuff. We get these nice little pull downs. We can work with the material. Hey, you might even be confined in weight. Maybe you know the amount of weight that the structure can take, and you want to keep it a little lighter. Maybe we go with aluminum, for example. So you can test all these things, right? We can start to see what this is going to look like. So now I'll just simply pick my positioning, and it's very easy to come in here and be able to put it in without using the constraining tools inside of Inventor, just using the frame generator tools that come inside of it. We're allowed to easily apply this and move on to the next member and keep using that numbering scheme that we came up with before, where I can tell it here it's a frame member, for example, and you start using the sequential numbers that we have associated to this. Making it a lot easier to keep track of these and not run into issues down the road where we have duplicate part number or file names. So really great technology we're seeing here. This, and what's even great is it's seamless, right? You're not seeing Vault pop up, and this is a dialog box that's popping up because of Vault, but yet we don't have to necessarily be into the Vault Explorer. We're just logged in. So we're creating these components. It's automatically naming that part for us, and we can move on to the next ones here. So we'll start populating the rest. Give me just a few moments. We'll just let it take on the next sequential number for channels here. You see how quickly this is. Imagine if I had to go through a whole library and choose this every single time. Right here, I could have changed the size of this right now if I wanted to. Flip this around. I have to use constraints, and a lot of times constraints actually bog down a large assembly. So we're seeing some great features here that are going to help you overall in your assembly process. We're almost done here. Zero. So we're just typing in the different rotations, how we want to align it. Pretty simple. While we're doing this, by the way, I'll just remind you that we're doing this using just standard Inventor. We're not using Inventor Professional or anything like that. We're able to very quickly get to all this information. Yeah. Now that we've got all these channels in place, what's important next is, well, hey, we need to fix up how these all intersect, right? We need to do some mitering, for example. For now, I'll turn off the visibility of that skeleton model that we were using, and I'll start doing some miters, for example. Notice there's a lot of different tools that help you out, like notching, for example. You can actually change these members out for a different size if you wanted to as well. So all these tools make it so much easier. Instead of having to open up the parts one by one, I can work in the context of the assembly and be able to quickly get those miters going with no confusion, no constraining needed, and I'm all done with the miters. Now the next part here we're seeing, of course I could have built this on the top of that skeleton, but I wanted to show you how you can use a trim extend. If I were to ask you to raise your hand and see how many of you have used trim or extend in AutoCAD, I'm sure a lot of you would. Right here what we're doing is we're simply able to select the geometry you want to keep and select what face it's going to, a lot like the trim extend command right inside of AutoCAD actually, or Inventor for that matter, by the way. And now we're able to trim all those members to that one face, and we're ready to go. Now we've got this started, let me save this, and we now know we're in the envelope here, we're within the constraints of this design, but now I'm going to open it up on its own actually. We can see it here a little bit better on its own. We can design some more. You know, hey, we need the platform on top too, by the way, right? So we can still do more than just the frame inside of this assembly. I can still use this create option where I can choose what type of part numbering scheme I'm going to use again, and be able to make the plate on top. Again, you can still add more to this if needed. So we'll just simply draw the plate that's going to go on top. And I like using my primitives myself here. And we'll go 0.5 inches. All we need to do now is simply constrain these two. A lot of different ways to do that, right? I'm going to make this a little quicker by just going to the edges, for example. Oops. Bring this back over here. Right there. Okay. And we'll let this rotate around and be able to constrain the final one. Ooh. Just one more time. There we go. Perfect. Now we got the beginnings to this. I can even go in here and I can specify the actual material for this as well. So we'll just make this one steel. And we have the beginnings to this frame assembly in just a matter of minutes. You know, something that usually would have taken you quite longer, right, if you were to do all of this one by one. So we were able to do this quickly and easily. We were able to automate those member insertions. The only constraint I did was the plate on top, and then we're able to put those end treatments on it. Again, there's a lot more end treatments that we can choose from, but that's just to get you started. Now, the other thing I want to talk about is what's the next step. So before I even go into documentation, I want to make sure that everything is good to go, that I can order the material and I'm going to be correct with everything. Did I Over-engineer, how much is really over-engineering? Let's be honest here. We keep saying over-engineering. I would have easily thrown a C6 on that, but I mean, is that double what I need? Is that triple? Is that even enough, actually? So we can design for all of these things using tools inside of Inventor, where we have an embedded solution that's using a Nastran solver. For those of you who don't know, that comes from NASA, actually. So we're able to use something that's tried and true inside of Inventor in a familiar interface without even having to leave Inventor. So let's do just that. Inside of Inventor here, I'll be able to go to my Environments tab and then start the Nastran, Autodesk Nastran In-CAD tool. So inside of Inventor, it's going to take all these frame members and turn them into beams for us. This is an easier way for it to solve, a faster way for it to solve, and a more accurate way as well. You'll notice on the left-hand side it made beams out of this for us. It still takes into mind the plate. The only thing I have to perhaps turn off, if anything, would be the skeleton or any additional things that might be reference things that you might not need. In this case, I picked up everything just fine, and I can start moving forward. So the next thing I'll do is, since the materials were already applied inside of Inventor, you remember these beams I chose as aluminum, and the plate is steel, so I don't even have to play with that. It brought it in for us. Next thing I'm going to do then is we want to be able to constrain this and say where it's actually being held down by. So I'll go down to these endpoints here, saying that these are actual fixed constraints. You know, of course, we can do the weight of itself on itself, but what we'll do is we'll put a load here. This is a maintenance platform. Let's say it was, 3 people on here. I'm going to just say each one weighs about 250, but no judgment on anybody there. We'll go and put it on the Z value. So we'll do 750 if my math is correct. Oh, I forgot to pick the face, of course. All right, and now we have a force going down right there. The next piece of this is we want to make sure we have a good mesh here. So what this means is how it's going to break it down. I'm going to bring the element size down quite a bit here and use my different settings in order to be able to create a mesh for this and have it break up into elements. At this point is we'll see that these beams actually get meshed as well, but it's a more accurate and a much simpler way to do this now. Now we've got the mesh, we've got the material constraints and loads, we're ready to go ahead and run this. So what you'll notice, it runs again right inside of Inventor. It runs it really quickly so we can see the results pretty instantaneous, I like to say, without having to exit Inventor at all. Just change that environment. I'm able to now go over to these results and be able to look at them. For example, let's say I wanted to look at the overall stress with the von Mises. Von Mises, I called it the first time, but after that, I never called it von Mises again. All right, so here we're seeing the maximum stresses. We're seeing the solid von Mises stress. We're seeing solid von Mises right now. Solid meaning we're looking at the plate, but if we want to look at the actual beams here, or the bars we call them, then I can go to bar von Mises stress as well and see what those maximum values are on the actual frame itself. Make sure that I'm going to be within my range of my yield. The yield for this material, I forgot to look up aluminum, but I think it's under 30,000 psi if I'm not mistaken. But we're still within our limit. But let's not guess. Let's find out exactly what that is. So I can actually go over to the other right here and choose that I want to look at safety factor. So the safety factor, for those of you who might not notice, work with that before, is looking at the ultimate yield strength of the material and then giving you what the actual stress on it is and letting you know what the safety factor is. So I'm well within that. The minimum right now I have is 30, just about 30, so I'm well beyond my yield. This should last me pretty long. But let's think of different scenarios. This platform could be for anything, not just a maintenance platform. It might be a motor, for example, or something like that. So we can easily come right back over to this simulation and be able to change this load without, again, needing to leave Inventor or anything like that. I'm going to go just a little more drastic here. We'll go with 20,000 pounds. That's a pretty big motor, I know. And we'll simply run this again. So you see how easy it is to do that. I could have also duplicated this simulation so that I can run it separately and be able to see what kind of results that would give me as well. I didn't have to change constraints or loads. It gives me all that. All I have to do now is just simply go to my results by double clicking, and it's going to show me, as well as an exaggerated look of the deformation on this part or this beam. And I'm at 1, so we can see the safety factor here. It definitely has changed, of course, because of the weight that's being applied on this. You know, if it really was only 3 people at all times, then we're good to go. Why would have I over-engineered it going with the C6 channel, which is going to cost us more? It's going to be more shipping weight, right? And it's going to be easier on the forklift as well. I know the forklifts can carry a lot of weight, but come on, let's try and make this as easy as we can, guys. Let's not over-engineer too much. I would call that over-engineering myself. This is one type of analysis we're running. We can get into a lot of different ones. I'll show you a couple more just to kind of show you some of the more capabilities we have. We could run vibration as well, so that we can see, if there's a specific frequency that we need to stay away from. You know, if I was to put a ball door motor on here, for example, that goes between 50 and 60 hertz, then we might be okay. I actually ran that earlier, and I noticed that after 66 hertz, there starts to be some displacement. So there's a lot of analysis like that you can actually do. What I'll do for right now is I'm actually going to change this into a fatigue model now. Let's see over time. Right now, it's safety factor's pretty good, but we want to see what's going to happen over time after maybe, I don't know, 1,000 cycles or something like that. So I can come over here to these materials and be able to assign to them the fatigue stress S and N curve for this. So we'll go ahead and type in the values here. Just give me 1 second. And we can even take a look at the XY plot. And something that I like to point out sometimes is, if you notice right now, a little pop-up came up actually that said that it's assuming 20% of the SU, so that if there's a piece of data that we didn't insert in here, it gives us a little hint, helps us out in order to be able to get the right information in here. So we'll go ahead with that. We'll click OK, and turning on the fatigue. Oh, we just need to do it for steel as well. 1 second. Turn on fatigue and insert some values here. All right. Make sure our XY plot looks as we expect. Looks good. Moving on. We've set it up to fatigue. We don't have to change anything because it took the same constraints, the same loads. All we had to do was insert the fatigue information, and now it's going to go through and run that for us. This one does take just a little bit longer, but not too bad. Now we can actually take a look at the results of the fatigue, and we can look at the life of this, of both the bar and the plate itself. So here at Datamax, looking the way it looks like it's infinity. So it is going to withstand these this weight that we put on here over its lifetime. If it didn't, it would tell us right here at how many cycles would it actually break. So these are results to be able to make sure that this design that we made is solid, that we don't have to worry about it. One last example I wanted to give you on this, I'll finish Nastran for this model, is I've been fortunate enough to work with one from Gobelco who supplied a model, and I just wanted to take a lot of the other stuff out and just look at the structure itself. Something else that you might consider looking at is, well, hey, we got to plan on putting this assembly in place. How do we do that? A lot of times you'll probably put like some dog ears on it. Sometimes it'll just be forklifts, maybe a crane or forklift where you tie things onto it. I've seen a lot of different things. I've actually broken concrete with a forklift on purpose. But here what we can do is we can say, well, we're putting a crane into this, and we want to see what's going to happen if we put some cables from the dog ears over to the crane, and we want to make sure it's not going to bow. So we have the capability of doing things like this in Nastran In-CAD so that you can have more confidence in the design, be able to plan around the actual shipment and the actual placement of these components, where you might take like this skid out there, for example, and then assemble the rest of it. So things like that can be done right inside of Nastran In-CAD without having to exit, right? But seeing the same interface that you're used to, where you can see this entire model and be able to run it and see what's going to happen. Is it actually going to bow in the middle? Right now I'm actually running a normal modes one that shows us if we had vibration in it, what would happen, what type of displacement would we actually have. So that's what you're seeing that's going to happen here in just a moment. And we're able to use things inside of Nastran In-CAD that allows us to actually simulate like a cable in here without actually drawing a cable. So even saves us a little bit more before I even move into the drawing section of this. I can take a look at these results and see what's going to happen at different frequencies in this case as far as displacement goes for this one model. Where we're seeing a little bit of we got a max of 2.5 in this model, for example, for this assembly, this frame structure. So we got a little bit of displacement going on there that we can see. I just wanted to show again the power that we have at our fingertips here to be able to use Nastran In-CAD inside of Inventor. So it's an embedded solution. It's a tried and true solver coming from NASA. You can definitely look it up and you'll find plenty of information. We can also provide that for you. It's in a familiar interface. It's inside of Inventor. If you ever use Inventor Professional's FEA capabilities, it's pretty similar to that actually. It's a very similar concept, but now you have a lot more capabilities that you have at your fingertips with Nastran In-CAD. So now let's take a look at the final step. Now that we've designed it, we've looked at the design where it's solid, it's good to go. Let's look at the documentation part of it. You know, a lot of times I've heard now more and more lately that people are going straight to fab, you know, maybe giving the CNC file or going straight to CNC, for example. But that's not always the case. A lot of times you still need a drawing, you still need a cut list. So we can create that accurately with the right information so that it's always also associated. So if the frame were to change, then the drawing changes, of course, as well. So let's go back over to Inventor and take a look at how we can do that. All right, with this model open, I'm going to go ahead and start a brand new drawing from here. Just a default drawing that I'm working with, nothing fancy here at this point. We're bringing in this model. You'll notice, if for some of you that might not be on 2017, there's some really nice tools here, capabilities to be able to get these views, these 3D projections of all of this. So that way I can always use this view cube instead of exiting the drawing mode. Now that we have these, I have some hidden lines turned on. I'll bring this into shaded mode, just a personal preference myself. Let's go ahead and start talking about dimensioning and parts list. Dimensioning, pretty simple to do, I'd like to say, where we can come in here and put our overall dimensions as we need to, of course, just like you might expect. We can also bring in the automatic dimensioning of all the components if we needed to for this model. I think what's going to really stand out here, though, is when I start ballooning this and wanting to actually get a parts list going for it. I'm actually going to do an auto balloon on this one, so make sure I don't miss any of the components. Highlight the components I want, have it ignore the same ones, and select the placement for it. With that said, I have all parts here. I can still move these balloons around as needed. You know, it just makes it faster if I can do an auto balloon. Then I'll go to my parts list. A lot of you might use, if you've been using Inventor for a while, then you might already be used to it. But what you're going to notice right now in just a second is now that I've got this parts list, it doesn't necessarily have all the information I need. So, for example, quantity that we're used to seeing the actual part count, we're seeing it with the full length of it. So I'm here to tell you this can be customized and this can be used in a manner that makes more sense to you. We can choose this parts list, and we can come over here and choose from different styles that I can have. So I did go in here and create my own style. These are things that we can teach you and show you through webinars and classes that we have. But we're able to come in here and use this style that has the actual item quantity on it, the part number, or it could be the file name, description, as well as what the length is for each part, and we can still have a total length at the end. So you can have all the information you need for this frame. Not just bits and pieces. This can all be done with very minimal amount of effort, actually. It's not like I have to go in here and write a custom program or anything like that. We can have all the information we need for this one assembly. This can also be exported, and we can even use features here to be able to say, well, you know, I don't want the plate. All I want is just all the cut list items. So what I'll do here, actually, just one last thing, I'm going to delete this last balloon for the plate. I just want the frame members. And I can turn on filters in here that allow me to say only show the parts that I want, basically. In this case, only ballooned items, so that the plate in here doesn't come, and it's really truly only a cut list, and I can rename this accordingly. I can even choose then to export it to Excel. Maybe send it to a customer, or maybe send it to the machine shop, the fab shop, or you can use Vault as well and export from there. A lot of different capabilities, a lot of different ways to do it. It's just a matter of how you need to do them. You can surely find a way for you. So we're able to create drawings that are 100% associative. If I go back in there and change the frame, this drawing changes as well. I can make detail views. I can add more dimensioning. I can now dimension those different structural members individually as well, and be able to get all the information I need quickly and easily without having to. At no point did I even open up the model. If I wanted to put more holes on it and things, sure, I can definitely do that as well. And most importantly, we get an accurate cut list. I've even seen people automate creating an Excel sheet from this bill of materials automatically every time you save. Just a few other tips and tricks, I guess you might say. So in summary, what we saw is we were able to make a frame quickly using the framing tools inside of Inventor. We use a tried and true analysis software called Nastran In-CAD, and we're able to make accurate documentation from it as well, all within the Autodesk solution set without ever exiting Inventor, actually.
Thanks, Jorge. So for the purpose of this exercise, Jorge used Inventor, he used the frame generator, he used Nastran In-CAD. That's basically, it can be plugged in directly within Inventor, and you can use it to do the analysis that Jorge has just shown. But Autodesk has invested more than $500 million in technology over the past 20 years. So if you have any challenges, that are related, for example, to computational fluid dynamics, you need to do any fluid flow analysis, composite structure problems, please talk to us. Autodesk has invested in those best-in-class technologies, and we're happy to help and guide you towards the right solution.
Right. And also, as kind of next steps, I guess, if you will, how do you get started? How do you start using this? It's inside the Product Design Industry Collection. If you have Product Design Suite, you have some of this capability already. And as Autodesk is transforming into giving you more options and capabilities, KETIV is doing the same thing. We're being an industry leader and making sure that you have focused training. So we no longer have, not no longer, on top of having essentials training, we also have different types of training where it's tailored and focused so that you get to learn Frame Generator for the way you need to use it. Tube and pipe design, if that's something you need to do, we show you how to do that. If you need to take these models and share them with architects so they put them in their models, we can show you how to do those workflows as well. So we have a full catalog of training courses that allow you to do this, and we can obviously give you more information, and it is on our website too. Under training, at the bottom you'll find the course catalog that we have come up with, and is actually getting a lot of hits, where we have a lot of customers now that are actually signing up for those types of courses. And one other thing is, I wanted to take a step back, and I thought, well, if someone is interested in using Nastran In-CAD, how can you get started? What we came up with was a little getting started kit, where with the new model that Autodesk has, and where you can have a subscription-based software. If you think about it, well, maybe a field fitter costs you $20,000. If you think about that, that's actually a very conservative number. I think there's a lot of you on the phone, on the webinar here, can agree and attest to having field fitters that are much more costly than that. But if we just look at that, and which is a very common value I've come across actually, if you invest under $400 a month, where you get the actual software, and we'll just do get started training for you for a half a day, just so you can get your feet wet, you can start playing with it, and then you can decide, maybe tutorials work for you. Maybe you want to come back and we give you some mentoring. We've done a lot of this, and it's something that you'll be able to take advantage of if you join this webinar, this Nastran Getting Started Kit.
So let's talk a little bit about promotions. KETIV and US Bank have a partnership, and we're able to offer a 1.9% financing for 12 months to our customers or new customer. If you have an interest, obviously you need to qualify. So we can take any question you might have about this financing options, offline. Also, Autodesk is offering a 3-year subscription program promotion. If you do have some legacy licenses that you want to trade in order to get the latest version of software from AutoCAD Inventor or the newest industry collection, please talk to us, Jorge and I. I think we have a slide at the end that shows our contact information. We're happy to take any question you might have offline and basically guide you to the right solution.
Yeah, it's a good point, actually. If you want to use the frame generator part with Nastran and Inventor, that's 2017 capability that was added, by the way. So if you do have Nastran today and you wanted to take advantage of that, 2017 is the way to go. All right, so we'll go into the question and answer portion of this. Let's bring out the questions. One second. Oh, we got quite a few here. So I'll read them off here first. The first one says, how does frame generator allow a ANSI 3x5 to be overrode with aluminum material and no longer be a C3? Okay, so basically the answer here is, or I'm sorry, the question is, frame generator allow me to put a C3 by 3.5 with aluminum. Inventor at this point doesn't have that, where it stops you from doing the design. It still is up to the user to make sure they're making a sound decision on this. Of course, in this case, I did use aluminum so that we can see, the ability to be able to change that material. I could change that material in Nastran and In-CAD without changing it in Inventor, so I can try those two different things. Let's see. I'm seeing here a question about from Tom saying, are the lengths adjusted in the cut list when trimmed or extended? And the answer is yes. So if you use those frame generator tools to do a miter or a trim or extend, the cut list is also adjusted to make sure that it's giving you the true length of that part. Let's see, the next one here. Glenn says, vibration of load if you add your motor or people moving. Yeah, you can definitely put a vibration in there. If there's anything from random vibration to direct response vibration, so there's different types of vibration. You can also do buckling, by the way. I meant to show that today, and I think I went over to the other model and didn't show that, but you can also do linear buckling, which will show you basically a safety factor to make sure that you're within the limits of the design that you're creating. I see another one from Glenn saying, oh, yes, Jeff, you wanted to add something there?
Oh, sorry. Just to kind of add on what you were saying, in addition to the vibration, if the dynamic loads are complex enough, you might do a like a transient dynamic analysis, which is also available in Nastran and CAD. So if it's more of a complex function than just a single sinusoidal excitation, you can opt for that approach, the transient dynamic approach.
Okay. All right, thanks, Jeff. Yep. I see another question from Glenn also about fork truck loading of skid onto truck, endpoint movement. So I'm assuming you mean be actually moving it and putting it onto the truck or seeing the load onto the truck. Yeah, you could definitely do that too. You can do. I'm sorry, I'm at a loss for a word here. You could do a nonlinear analysis as well, where you can actually see movement and be able to put it down and see what that load is. As a matter of fact, there's even a drop test option here to do inside of Nastran and CAD. Did you agree there, Jeff, too?
Yes, I agree with that. Yeah, again, another possible approach with a transient dynamic option.
Got it. All right, I'm seeing here from Tom, is the cut list exported to Excel? Does it update when adding items? So it doesn't update automatically. You would have to export it again. There are ways to get it to export automatically with the update, like let's say if on a trigger on a save using the iLogic tools inside of Inventor, actually. So if that is something you want to know more about, you can definitely reach out or talk to us afterwards, and that is something that is possible. All right. I see Glenn. If you wanna, if you can kind of rephrase that, you say how much deflection, I'm assuming. So if you can elaborate a little bit on that, I'd be glad to try and answer your question. Let's see, we got another one here. Amir is asking if we can go back to the results of the skid with the cables and review the results. Yeah, we surely can. Let's make sure we answer some of the questions first, and then we can go back to that in just a moment. All right, let's see. Do we have any more questions? Nope. Bring that back. Thought I saw a couple other ones.
He just added. Could you show deflection from an explosion?
Jeff, can you help me with this? Maybe it says, could you show deflection from an explosion?
Explosion, okay. The thing with an explosion is you would have to quantify the load coming from it. It's not it doesn't have an explicit dynamic solver like what you might have to model the explosion along with the deflection. All you have here is just the standard implicit solvers, which is your typical transient dynamic and linear static and so forth, as well as some nonlinear solvers, whereas something with an explosion itself, modeling the explosion itself, would be more of an equation of state, which isn't part of the Nastran solver. But what you could do is get some sort of whatever shock load or concussive load from that explosion and apply it as most likely a transient load, again, a time-varying load on the structure, and you can calculate it that way. Or you might even do a pseudostatic analysis where you get sort of an equivalent dynamic load and apply it in a static analysis. So you do have options there. You just wouldn't be able to model the explosion itself explicitly.
Okay. Yeah. It'd be a way of doing it at least, yeah. Okay. Mm-hmm. I see Glenn did elaborate here. Via fork truck loading was total deflection of one end loading and stress on skid components. So if I understand that correctly, you're talking about fork truck loading, let's see, and having deflection on one end loading and stress on skid components. I believe you're meaning basically if you are putting it on the actual bed of the truck and you want to see the stress on the skid components, yeah, you would see that actually inside of there. It's just a matter of, again, the setup and everything. You can change between the skid components and the actual 3D solid components as well. Those two are split up into two different results.
Yeah. Okay. Kind of breaking it up, I kind of wonder if there's the question kind of entails the types of loads available, like enforced displacement versus a force and so forth, and all of that's available. Pretty much every type of load that might be applied to something, whether it's imposing a displacement on something, or applying a load, or applying a pressure, that's all available within Nastran and CAD.
That's right. That's right. All right, and then Stephen I think it was more of a comment, says something about an aluminum-specific profile needs to be developed. So I think that reminds me of something else, is that the frame generator is using the structural components that come inside of Content Center. So really, whatever's available in Content Center is what's going to show up in Frame Generator. So if you didn't want one of those to show up, if you feel it's not appropriate to have that option, that can be taken off in Content Center, as well as you can add more components to that. I hope that I guess, or that should hopefully answer your question there. Is it Stefan, I think, on here. All right. It looks like that's all the questions we have here today. I'd like to thank you all for joining us. I hope this was useful for everybody going through the entire design process. If you have any questions, let us know. We'll take another look at these questions that we have here today and make sure that we answered all of them. And if we missed one of you, we'll make sure to get back to you. All right. Thank you, everybody, for joining, and we'll see you next time.